So you're going to prepare Benedict's solution, and a Benedict solution is used in biology experiments and practicals. It is used as an indicator for simple sugars. So Benedict solution is blue in color. It is blue in color. It is blue in color, and the color changes when it is being used in presence of the simple sugars as follows. So you're going to observe the color change. It's going to change from blue to the following colors. So you're going to have orange color. Orange color. This one indicates the high amount of reducing sugars or simple sugars. Reducing sugars or simple sugars. The color also can come to yellow. This one indicates average amount of reducing sugars. It can also change to green. This one shows that there is a low amount of reducing sugars. So these are the colors that change, that appears whenever there's a presence of simple sugars, whenever you are using Benedict's solution. Whenever you are using Benedict's solution. Again, let's look at the requirements that are needed when you are preparing Benedict's solution. The requirements for preparation of Benedict's solution. Number one, requirements that we need is actually, you are going to need three major reagents. So the first reagent is actually trisodium citrate. So this one is trisodium citrate is C5H6O7, sodium 3 and 2 water of crystallization, 2 moles of water of crystallization. Here we need 173 grams of trisodium citrate, and then we are going to need also 100 grams of sodium carbonate. This is sodium carbonate, 100 grams of sodium carbonate. And then we are going also to use 17.3 grams of copper 2 sulfate. This is copper 2 sulfate. These are the requirements that we need. Other requirements that are commonly used are, actually, you should know that we need, we are going to require distilled water. We are going to use also a 1000 ml volumetric flask. Remember, we are going to prepare 1 liter. So we have some source of heat and some boiling water here. We have also, this is copper 2 sulfate, 17.3 grams of copper 2 sulfate. We have 173 grams of trisodium citrate, and then we are going to have 100 grams of sodium carbonate. So I have my stirring rod. This is my glass beaker, and this is my filter funnel that I'm going to use to deliver it into the volumetric flask. Now, how you are going to start is, the reason why I'm boiling the water is actually to speed up the rate at which these two salts are going to dissolve. In fact, we are going to start, and then we shall see what happens. So it is going to be more of demonstration than actually writing. So I'm going to start with 173 grams of sodium citrate, that is trisodium citrate, and 100 grams of sodium carbonate. So what you do is that you mix the two. You take 100 grams of sodium carbonate and 173 grams of sodium citrate, and then you mix the two in one beaker. This is 600 ml glass beaker. So that is what I'm going to do there. That is my sodium carbonate. Then again I have sodium citrate. There we go, sodium citrate. Then I mix the two. Yes, I'm mixing the two. Like that. I'm mixing the two. That is it. So we are going to measure using measuring cylinder. We are going to measure around 500 ml of distilled water. This is the hot water that we are going to use. So we are going to use measuring cylinder to measure 500 centimeters cube, of distilled water, where we are going to react. So I will make a solution of a mixture of sodium citrate and sodium carbonate separated with, I'll make also separate solution of copper 2 sulfate. So here I have a 1000 ml measuring cylinder. So let me use this one. So I'm switching off the flame. So I have hot water. So I will measure about even 500 is okay, or 400 there, it's okay also. So I have 400. Let me use 400 ml of distilled water. That is around 400 ml of distilled water. And then add to the mixture. Then I will use my stirring rod to make sure the two are actually dissolving. This is my stirring rod. So I will continue stirring the two until they dissolve. If it's not going to dissolve, that means it is a saturated solution. I'll need to add more water. So I may add 100 ml of water. About 100. It's about 100 ml of water to ensure that it is going to dissolve. So continue stirring the two. So that's it. So I'll also prepare a separate solution of copper 2 sulfate. I may need some more boiling water. So we may as well continue stirring the two to ensure that they are dissolving. So our target is to prepare 1 liter of the same. Our target is to prepare 1 liter of Benedict's solution. So this one here is okay. This one has dissolved. Now we wait for the one for copper 2 sulfate. So remember, you need to add, you mix the two, copper 2 sulfate, the sodium carbonate and sodium citrate separately, and then prepare this one separately. So we are going to dissolve the copper 2 sulfate. So I'm going to use about 100 ml also of distilled water. It is a separate 100 ml. There we go. So this one is 100 ml of copper 2 sulfate. That's it. So I'm going to stir it. So maybe I'm going to rinse this one, then stir to ensure that it is actually dissolving. So my copper 2 sulfate solution has dissolved. This is distilled water. So I can transfer this one to a better jug that I am using it. So what you do next is actually to deliver sodium sulfate into this solution slowly as you stir. So this is what you do. As you stir the two, ensure that you are stirring as you add the two. So that is it. So this is my Benedict's solution that is almost ready. Keep on stirring the two. And then after that, transfer the mixture of the 3 solutions into a 1 liter volumetric flask. This is what I'm doing. 1 liter volumetric flask. I'm transferring into a 1 liter volumetric flask. Now that is my mixture. Now what follows is actually to top up the solution to 1 liter. You top up to 1 liter. You top up to 1 liter, the mark, then up to there. Then we shake to allow the mixture to form a uniform solution. So then top up to 1 liter of the same solution. So that is what we are doing now. We are topping up to 1 liter. So what will follow is actually to label our solution, and it is ready for use in the laboratory. So that is it. So this is 1 liter mark. So our Benedict's solution is now ready for use. Our Benedict's solution is now ready for use. So I'm going to label it, ensure that any other reagent that is prepared in the lab is labeled. So this is Benedict's solution. So I'm labeling it, and then our Benedict's solution is ready to use. So this is Benedict's solution. It's an indicator for simple sugars. So thank you for watching. I'm not a teacher, but take the content of my work. So be sure to subscribe to my channel and leave a comment. So thank you for watching.